So let me share my screen. So good morning, good afternoon, good evening, everyone, depending on where you are on Earth. So today we are going to continue from where we stopped. I think we were discussing about modifying a list in a function. I think we stop here, yes? So let's make a recap of what have been treated. So let's see how a program can modify a list in a particular function. So let's get back a bit and see the function we have. So let's look at this function. So we have a function called greet users. The function receives a parameter, or it has a parameter called names, like this. It's only one. So when we call this function expects us or expects the users to send an argument. Look at this. Here we have a list here. The list has 3 items. So here we are calling the function and we set the argument of this function to be this list. So when we call the function by its name here, greet the user. So this value, or the value in this variable, will be transferred to this variable called names. So inside the function, we have a for loop which iterates through the names. So for every name in names, here we have this statement, which takes the name and capitalize the first letter, then we store it in the message, then next we print it. So let's see the output. So this is it. So we have this Hannah, and we have Tai, and we have Margot. So these are the output. So let's move to the next. We already have the function. So a list can be modified in a function when you call a function with that list. So let's see this. Here we have a list with 3 items. Here we have an empty list with nothing in it. So what we do here is a while loop. So when we iterate through the list, first what we do is we remove an element from the list. So we take this element, then we put it here, then we print it. Then next we append that element that we fourth from this list. So at the end, here we have this line 11. What it does is we just print the string here. The following models have been printed. So here we iterate through this list, that's the second list. Here we print. So when we run this, this will be the output. So we already discussed this in our previous lecture. That's why I'm going as fast as possible. So I know that you don't have any question here. If there is, you can ask question before we go to the next segment.
Sir,
Yes.
I think I raised a concern in the Telegram group, sir. The last recording, I don't know whether it is from my own side, but it is not playing sound.
Okay, there wasn't sound.
Yes, sir.
At
The
the
last, I
end,
think the sound the sound stops at 20 minutes, and while the entire recording
I
is
think
one
it's
hour.
from
So
you. It's
Definitely,
probably
you can go to YouTube channel and maybe you can download the lecture or you can listen online. From what I
okay,
saw, it was
I down-
working. The sound
I
was fine.
downloaded. Okay,
Yes, so this means that this function, or we can modify a list here, though it is not in a function here because we don't have any function here, but we are modifying a list here. We copy from this using this function. We are removing items one by one and storing it here. So we can organize this code by writing two functions here. So this one, we didn't use any function here because you didn't see any def to define a function. So we didn't use that. So we can organize this code. We can organize our code by using functions. So the function is used to organize, maybe you can just organize the code that are related into functions. So what we are going to do is we are going to reorganize this code. This one is also organized, but we are going to reorganize it. To reorganize it, what we are going to do, we are going to write two different functions, and each of which does a specific job. So that's the use of the function. When you have a very lengthy code or complicated code, you can group some specific codes that do a specific job. So you can make it a function. So this is what we are going to do now. We are going to create two functions. Each one does a specific job related to what it does. So most of the code won't change. Uh, we were just structuring it more carefully. So the first function will handle printing the design, and the second will summarize the print. So let's see it. So this is the first function, print model. So this print model function accepts two parameters. As you see, we have unprinted design and completed design as we have here. Look at it, we have unprinted design and we have complete model. Then later we make a print here. So it has two parameters. Then inside it, we have a while loop similar to the above. Here we make a copy from the original list to our new list. Remember, we use this word append to add items to list. Then we have another function, show completed models. So it receives uh, one parameter, as you can see, completed model. Then what it does here, it prints the completed model here. So this code is similar to this one. So we make this the second function, while this code in the first function. So now how do we call a function? First, we need to supply the data. We need to define the data or declare the data that we want to pass to the function. So we have it here, that the first list, then the second list, which is empty, is here. Then here, we call a function. Remember, we call a function with its name. So here we are saying, hey, print model, I have some data that I want them processed. Then these are the data we submit, or we call the function with these two different data. So this function will receive the data here, the first one here, the second one here, then here we make the processing here. Then after the processing, the data is stored in the memory of the computer. Then we call another function, which is the second function here, completed models. Then we send this argument for printing. So it receives this data, then it iterates through the data, and fourth, iterates through this data, taking one item at a time to this variable, then we print the result here. So let's see how it works. So this is the result. Yes, good. Any question about this? So no question. Next, we define a function print models as you see here. We have a function print models here. This is the function print model with two parameters, as I already explained. So this is the explanation of how these things work. So this is what we do. We provide the data, then we supplied an empty list, then we pass these two lists to the function, then we call the model here, or we call the function here, then the function make the processing, then here we call another function to print the result. So if you notice that our list has been modified by the first function because it keeps removing items from this list unprinted design until it is empty. Then it keeps populating this empty array until it is full, until we exhausted our items here. So how do we prevent that? Sometimes we may need to prevent our list from changing. So how do we do that? To do that, what we are going to do is we are going to define a function, but instead of creating a just normal variable, then we create a variable that we make it possible to copy the list instead of just passing the entire list. So how do we do that? We do that by writing a variable name with this square bracket. Then within the square brackets, we put this color. So this makes sure that the list is copied instead of creating an object that reference the original list. Do we understand the point here?
No, sir.
Okay, so let's move. So this is the line here. So like this, look at this. So we have this. Here, we are creating a copy. You remember when we have a list, let's see. Let's say we have lists, let's call it list A. Then we can have this here. So then if we write list B, for example, and instead of putting items here, so we can write list A here. So what I'm going to do here, let me print list A. Let's print list B. So it looks like here, it looks, by me looking, as if we are copying list A to list B. But let's make some changes to list A and C. Let's say we have list A. So let me do this. So list A, we have phone case. So here I'm referring to the first item in the list A. Then instead of having phone case, let's call it phone charger. So let's do this. So what the meaning of this line? Can anyone tell me what I did here?
Sir,
What happened?
I think, sir, you are trying to replace phone case with phone charger.
Yes, exactly. So we can here is phone charger. So which list which item which list am I modifying here?
Modifying list A, right?
List A. So let's do something. Now let's print list B and see. So look at here, I'm printing list B, but look at what happens. Why is this?
That is, I think, because list A is equal to list
A
B.
is equal to list B. If you modify list A, definitely list B
Yes,
will be
it will
modified.
automatically modify list B.
Yes, because here I have this object which points to this. So when I do this, I'm creating another object which points to a location whereby this data is stored. So if I keep doing this, I'm just creating an object that points to where this data are stored. That's why when we change any of this one, then when you print any of the objects that we refer using this will be changed as well. So if you want to make a copy, what you just need to do is to maybe use, let's create another, let's call list C. Then we do this. So instead of doing that, we can do this, for example. When we do this, let's do this. So let's print list A as well as list C. So look at what happens. So we have phone charger. So if we change this, let's make it phone case again. Let's modify the first list A. So now let's reprint this. So you see, list A has been changed while list C remains intact. No change. So this one is not affected. So if you really want to copy a list, this is how to do it. Although there are many ways, you can use function to do it. So this is one way of copying a list. Maybe later we will talk about shallow and deep copy. So the same thing applies to this. So we have this. When we do this, we are really copying the list. Yeah. So when we run this, so we are sending a copy of the list instead of sending the list in its entirety. So this is how to avoid modifying your list. Any question? So no question. So when we are creating functions, so what we usually do, we decide whether our function, Abubakar, you are missing the screen by drawing arbitrary drawings. So when we want to define a function, so we decide whether our function receive parameters or not. Some functions do not receive any parameters, while some do receive. So sometimes you may know the number of parameters that your function may receive. Sometimes you may not. So depending on the user can send as many parameters as he can. So let's see one example of such. We've been using print function. What will happen if I use print function like this? Will it work? It will definitely work, yes? So you see it works. No error, nothing. It will just print a blank line. So what if I use another print function with an argument like this? Maybe let's say I have hello. Will it work? It will still work. Look at the number of argument I sent. So I have one argument here. It will work. If I like, I can send two arguments at a time. I can say print, I have hello. Then I have comma. Okay, let me do this. I have comma, and I can have world. So look at this. I have two. We call the function without any argument. The second one, we call it with one argument. The third, we call it with two arguments. And you can almost call it with any number of arguments. So the same thing applies to this. How can we create a function with this kind of arbitrary number of arguments? You see that this is 0 argument, this is 1, these are 2 arguments. And we can call it with n number of arguments. So how can we do that? So let's see the first example. So look at this example. When creating a function, okay, let's read this first. So sometimes you want to know ahead of time how many argument a function needs to accept. You may not know sometimes you may know. So unfortunately, Python allows a function to collect an arbitrary number of arguments from the calling statement. The function in the following example has one parameter. So that's this one. So the parameter is called toppings. But this parameter collects as many arguments as the calling line provides. So it is the calling line that decides how many number of arguments we need. So in short, what this does when you declare a variable and you pre-append it with an asterisk, it means that the function can receive n number of arguments. N number of arguments. So let's see this. So here we are calling the function with one argument. Here we are calling it with 3 different arguments. So let's see the output, how it works. So you see, when we run it here, the function receives the items here in this variable, then it prints the contents stored in the variable. So the first function send only the first call sends only one items. That's why we have only one item here. So the second call to the function provide 3 different items. That's why we have these 3 different items. So what type of variable is this? Which class do this belongs? Is it a dictionary? A list?
TOEFL, sir.
Yes,
TOEFL.
it's tuple. As you can see, it's tuple. It's tuple that has this kind of bracket. So it's tuple. So if you want, you can iterate through the items. So we know how to iterate using for loop. So the asterisk in the variable name, toppings, tells the Python to make a tuple called toppings. So containing all the values this function receives. So all the values will be stored here. So when you call the function with maybe hundreds of values here, so all the items will be stored in this variable. So the function will just receive however number of values you have. Then now we can replace the print function if we want. Call a loop that runs through the list of toppings and describe the pixel being ordered. So look at this. So we are just going to modify this code. Instead of printing the toppings, so we can iterate through the toppings. So let's do it. How do we iterate? We can use for loop and we can use while loop. But as usual, we use this together with in function. So this will iterate through the toppings here. Then here we print the toppings. So let's run this and see this. So that's why we have only one items, while in the second call we have 3 different items. That's why we have 3 different items. Any question on this?
Sir, please, I have a question regarding the print command there. Print
Okay.
bracket. What about that hyphen that you put after the
Yes,
F?
this hyphen is just just a way of beautifying your code. Look at this. If you like, you can put star. Look at what we do when we want to maybe when we want to make our code or writing books more beautiful. So this is what we do. Sometimes let's see this markdown. So sometimes you can put asterisk and put maybe make. Let's say we have this. So look at this. Look at this. So when I run this, look at what we have. So we have this. You see, we have this dot dot. So if you like, you can put whatever you want. You can put hash there. If you put hash there, sorry. So you can put hash or you can put star there. So when you put star, look at the output. So you see now I have star there, asterisk. You get
Yes,
it?
sir.
So it's as ABC. If you like, you can put numbers here. So you can put a counter here. Maybe you can say counter. You give it, yes, 0. 0 is fine. So in it here, you can write counter plus equals to 1, for example. So instead of putting this, so we can do like this, then we can say counter like this. So now we have the counter. So when you print, you have here you have 1, here you have 1, 2, 3. You get it. It's as simple as ABC. You understand, yes? The reason why we use dash is just to beautify our,
Okay,
to
sir. Thank you
make
very much. Thank you
file
very much.
out.
Thank you very much, sir.
So sometimes, let's say you are creating a function. So the function, what the function will do is to sum numbers. Let's do it together. How are we going to define a function that sum numbers? First, we write def, yes? Then we write the name of the function. Let's say some numbers. Yes? Then definitely there is going to be number of arguments. The number of argument can be num1, for example. That is, let's call it num1. Then we can have num2, like this. Then, so this is how to define a function, as simple as ABC. So when we run this function, look at what we have. So when you want to call your function, how do we call it? We just call some numbers, then you supply the numbers. Let's say you want to sum 2 and 3. This is how to do it. Because the function returns values, so we can just print the values returns by the function. So we can do this. We can do this. So when we run this, so this is the output. So if you want to maybe add 7 and 3, then the function can do. So what if we want to add arbitrary number of values here? Maybe I can do this, 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 just like this one. So the user can decide how many numbers he wants to add. So maybe you can do it with this, the same way we do this. So you can create a variable here in this format, star, and then the name of the variable, you can call it numbers, then you can iterate through the numbers and keep adding. We understand. So let's go to the next section, that is mixing positional arguments. The positional argument is like this one. When we call this function, with 7 and 3, what happens is that this 7 goes to this num1 because it is the first argument here. So it will go to the first parameter here. While here is the second argument, and it will go to the second parameter here. So these are the position. This one is the first position, this one is the second position. So these are positional argument. When you interchange them, there is going to be a problem. Let's maybe demonstrate that. Let's say we are defining a function that prints the name of a person. So let's call it print. Let's call it student details or name. Let's call it name. So here we receive the first name. Then here we have print. Then we need to format this. Then we write your first name is, then yes, just like this. So we don't need this sign at all. So look at this. We have this kind of function. So what the function does, it will print the first name and the last name. So let's run this. So we have our function defined. Remember, we know how to define a function. We use this keyword, then the name of the function, then the list parameter list here, then we have colon, then we press enter and indent and write anything under the function. So now let's call the function because the function is just going to print. So let's call it with print. Print student name. So instead of, let's put the name, let's put a name that is Mary. Let's use Kaduna style. So you see the first name is Mary, while the last name is Adamu. So let's copy this. Oh, sorry. Let's call the function again with these values interchanged. So let's do this. So look at this. So when we run this, look at what happens. Your first name is Mary, while this one, your first name is Adamu, which is very wrong because we use positional arguments here. So depending on the position of the argument. So when you interchange, there will be a problem. So how can we mix positional argument and arbitrary argument? So arbitrary argument is the one that we use, we append it with star before the name of the variable. So how can we mix them just like that, or there are rules that guides mixing them together? There are rules. So to allow a function to accept several different kinds of argument, the parameter for arbitrary argument must be placed last in the function definition. So when you want to define a function, so you have to put the variable that is going to hold arbitrary number of arguments should be the last one. That's the rule. Must be the last. So it is a must that arbitrary argument must be the last in the function definition. So Python process positional and keyword argument first. So you have to put your positional or keyword argument. We discussed about keyword argument, whereby we use the name of the parameter when calling the function, where we say we need to know in advance the name of the parameters when we want to call a keyword argument. So in keyword argument, when calling, you can just mix them. It's not like positional argument. So you have to place the positional and keyword argument first before the arbitrary argument. So this is the example here. So here we have a function called make pixel. Then we have this argument, then we have the arbitrary argument here. So here we call the function with this, so this one goes to the first, while this one goes to the next. So now, what happens if we put toppings at first? You are going to confuse Phython. How many number of arguments are here? How many are not here? That's why it is advisable to use positional and keyword argument first. So now let's run this. So this is it. This is the output. This 16 goes to the size, and this 12 goes to the size as well. While this one, Ronnie, goes to the toppings in the first call of the function. In the second call, we have all of these items goes to the toppings. So that's why we have 3 when we iterate through the toppings. This is what we have. We have 3 for the second call, while we have 1 for the first call. So here is another example whereby we have the using arbitrary keyword arguments. So the function build profile. So here we are going to define another function called build profile. It receives the first name, last name, and user information. So user information can take can assume many forms here. It can take number of items. It can be 1, 2, 3, etc. So the function, what it does, it creates a dictionary. So this is how we do it. First, we have the dictionary, then we supply the key here. The first name is the key, and this, the value it received, the first one will be assigned to the first name. The second one will be assigned to the last name, and returns the user info here. So now let's run this. So you see what we have here. We have the Albert, then second we have Einstein, then we have location here. So the location, we have this, then we have the field here. So this is the output. So as simple as ABC as well.
So I have a question.
Yes.
So I can see while defining the function, can you please just, yes, sir. It's okay. I see while defining the function, we just, you just wrote first, last, you didn't complete it with first name, last name. And under that, I saw that you added user info, first name, last name. So don't you think that will give an error, or how do you tend to like make it possible for us to like have an output this way? I don't know whether I get
Yes,
me.
I don't understand the question. Look at this.
So for example, now here while defining the function, you wrote define build
Yes, here
profile.
while defining the function, we have 3
Last,
different parameters. Yes.
yes, you didn't put first name, last name, and there under user info, you wrote first name, and then okay.
Yes, the reason being is here is just a value. This variable contains the value. So this first name contains Albert, while last here, first, content is just a variable in the memory. And this variable will not exist until we call the function. So when we call the function, it is only when this variable will be created. This is just local variable. So when this variable is created, this value all parts will be stored in this. While this value Einstein will be stored here. You understand?
Okay. Yes, sir.
So Einstein will be stored here. Because this one we use keyword argument. So it's already key and value here. So when we return the user info here, you understand? When we return the
Yes, sir.
user info here, this is what we have. Because here is a key, here is a value. Here is a key, here is a value. So that's why we just return the user info here. You
Okay, I understand,
understand?
sir. I understand. Yes, sir.
Okay. So that's why we have this.
Hello, sir.
Yes.
So after defining your function, in the second line, you put double quotes 3 times, and then you write fill a dictionary containing everything we know about a user, and then you close it with another 3 different double quotes. So in this case, what are you telling? I mean, what are you asking the Python to do?
So what this line does, I think Dr. Shamsuddin taught you about comment. This line will not be executed by the compiler. It's just for me, who am I who I am the one who writing the code, or someone who is going to read my code will know what is going to happen under this line. It's just a comment about
Okay, sir.
this line.
Okay, sir. I never knew that. Okay, sir. I never knew that in writing comment,
Yes, it's just a
we
comment.
can use
If you
double
like,
quotes.
you can delete it, you can remove it, nothing will happen. So when you run, you will see the same output, you see?
Yes, sir.
So it's just an information about what I'm doing here. So I'm
Yes.
building a dictionary containing all the user's information.
Yes, sir.
Yes?
I got to understand about the comment. What I usually see is by use of hash.
Yes. Yes.
Okay, but I never knew that we can use double quote.
Yes, you can use it. It's triple quotes. It's not double.
Okay. Okay,
It's
yeah,
triple.
triple quote. So it's all the
So
same thing as using hash.
yes, so if
Hash
you
symbol.
want to use multi-line comments, you use this. If you want to use single-line comment, you can use a hash. And this kind of comments is usually found in method.
Okay.
Yes.
Thank you so much, sir.
So I think there is no question now. Let's move to this because this one is very important in tomorrow's class. Tomorrow we are going to talk about OOP.
Sir,
So this is very, very important.
before arbitrary comments, you used to put a double star. What if you take it out?
No, you will get an error because here we are referring to keyword argument, arbitrary keyword argument. So it's not like the previous one. So when you read the book, you will see, though they didn't discuss it in details. So this one is keyword argument. So sometimes you may work in a project with different people, or you have a project that maybe has many lines of code. So sometimes you need to organize your code into functions and then into modules, whereby this module contain this kind of things is going to solve this kind of problems. Imagine you are creating maybe a package to solve mathematical problems. You know, in mathematics, we have logarithm, we have maybe linear equations, we have geometry, we have many things. So now you want to maybe create a package for solving all the mathematical problems, maybe about maybe your egg or NECO, so that the users don't need to suffer a lot. So you provide them with the function. You just call the function and just use it. So you can use you can store all the function in module. So what is module or modules? So what function does? Functions help separate blocks of code from the main program. So you organize your code into function that performs a specific job or task. So making your program easier to follow. So using descriptive function names improves readability and understanding of the program, other than writing your maybe lengthy code. You need to organize your code into functions so that everyone who read your code will just understand. Then function can be stored in a separate file if you like. You can just create a separate file, your maybe .py file, and just call it a model, for example. Then you can import it into the main program using import statement. So we haven't used import statement since the inception of this program, but later we will start using it when we come to maybe perform some more advanced things. So storing function in modules allows, that's the advantage of using of storing function in a module. So it allows us to hide code. For example, the print function we've been using the print function, but we don't know how it works. We don't know the code behind the print function. We just use it. We just write print and it works. We use sum. We use title. We don't know how it works. So you can hide the details of your code. So focusing on high level logic. So you may have like 100 lines of code somewhere, stored somewhere. Then here you can just use it. Just like the SMS you use in your phone, or you just dial your friend's number, for mobile number, you just call him. But you don't know what happens behind the scene. You have a car, you just key in the car, then you just start working. You just press brake, you press accelerator, but you don't know what is happening behind the scene. So the same thing applies to module. You can hide the complexity of your code, so that you can just focusing on the high level implementation of your program. And it can also happen when you are doing group project. Yeah, you may be given some tasks to do. Maybe you are working on a bank application. You are creating a very good banking application. So someone, you may be assigned a task for maybe to handle transfer from one account to another. So you write your maybe 1,000 lines of code, but instead of just giving the code to someone, you can just give the function to someone. So maybe the other user, what they will do, they will just write transfer from, that's the name of the function. Then they provide the first the source account, destination account, then maybe the bank name, the source bank name, then maybe destination bank name, then the account number. So maybe you have like 5 parameters. So you just give it to the other person. So he will just use it without knowing how your code works. So that's the use of this module. And another advantage is reusing function across different programs. So when you define your function in a module, what you just need to do, you just import it. Import the module, then you can use the functionalities stored in the module. So this is very important. It allows reusability. You can reuse, you keep reusing the function. Remember how we keep reusing print function. Everywhere we just use print function. So imagine we have to rewrite the function. So this is going to be tedious. But when we define it, you can use it number of times we want. You can use it 100 times, 1,000 times, million times. So, and again, sharing. So sharing individual modules with other programmers without sharing the entire program. So you can just share the modules with the others. Imagine you are creating a new package for people to use, maybe for your society, they can use it, or you understand that this module is not available, so you can provide it to other programmers so that they can just use pip install, then the name of your package. So you can contribute using this kind of module. So importing function enable access to libraries written by others programmers. So later we are going to maybe import NumPy, we are going to import Pandas, we are going to import many libraries. There are many libraries, thousands, tens of thousands or hundreds of thousands of libraries that we can import and use. And these libraries are written by individual persons like you. So you can just have the desire to create your own module. So there are multiple ways to import modules, which can be briefly explored here. So first one is to import the entire module. So before going to that, how do we create a module? To create a module, what you just need to do is just to create a normal Python file. Just name it any name, but make sure that you provide a good name for your module. Just provide a good name, and it will reflect what problem you are going to solve. So to start importing function, we first need to create a module. A module is a file ending in .py, which means it's a Python file. This file name extension .py means that the file is a Python file and contains the code you want to import to your program. So when you create the file, you save it with a name, and with a name is the file name extension .py, then you include the code you want to import to your program. So in this, we are going to create a module here. The modules is going to contain a function called make pixel. So we create an empty file, pixel.py. Then we define a function, make pixel, in that file, just like what you see here. So when we create the file, we are going to just copy and paste this code in that file. So let's see, I have already created the file here. So this is it, pixel. So look at the pixel here. So this is normal function, but instead of putting it in the notebook file here, I just decided to create a module, and I name that module fixer.py. And inside that file, I create a function. You can create as many functions as you can here. You can create as many functions as you can here. So when you try to import, you can import the entire module, or you import a function that you want to import. So remember, if you come from Java, you know how to use that star to import every function in a particular package. So already I have this module here. So to import it, what you just need to do is to use this keyword import. Then the name of your module here, which is Pixar. So when you write this code, what Phython will do, the Phython will import all the functionalities stored, all the functions stored in the file Pixar. So if you have many functions here, so Phython will import to your program all the functions here so that you can use them. So when we import Pixar, there is a function called make Pixar. You see it here, make Pixar. So we can use that function because we import this module. If we decided to comment this line, let's run this and see. So you see we have an error. Name fixer is not defined. See? And we can neither use make Pixar here. So the name Pixar is not defined. Even if we remove this, already we defined this in a module, so it will work because we already defined this function. But imagine that we didn't define it before, then this will give another error. So let's uncomment this line. So, and import the function. So this, we are importing the module, and the module contains this function in it so that we can use it. So now it works, you see. When we import this one, so we can use this to access the function. It's just like the object you have when we come to object-oriented programming. We create an object, then we can use that object to access the function.
So
in it,
I'm not
or
clear with it.
properties or whatever.
So I'm not clear with the problem you have solved. The question
So the problem we are trying to solve here is how can we organize our code into modules? To organize your code into modules, first you need to organize your complex code into functions.
I get
Every
that one.
function has specific tasks or has specific problem that
And the name.
is going to solve. So to create a module, what you just need to do is to create a file, just normal file. But the file name extension must be .py. So it's just Python file. So in that Python file, you create the function. Just create a function which you can call when you import the package. For example, here we import the package. So when we import this package, there are many functions that this package can provide. Let's see one example. Let me import, let's call pandas. For example, we are going to import pandas. So I'm importing pandas here. So look at what happens here. When I import pandas, because it's quite heavy, so look, I import pandas. So here I can say pandas dot. So there are many things here. You see pandas here, pandas.read. All these are functions that I can use in pandas. I can say pandas.read underscore CSB, for example. This is a function that I can use from pandas. There are many functions because here is not only one. Pandas.read Excel, you see, I can use this. It's another function in pandas. You can say pandas this, look at the read JSON. But our function here has only one, our module has only one function here. That's why we have this main. If you look at it, we have only one function here. That's why when you write fixer dot, you see we have only one function here. You see, we have only one function, no any other function in it. But with pandas, we have many functions in it. So we get the same output, but here we organize our code and we hide the functionalities in the code. Look at the original make pixar. So look at it. This is the original code, but here we are just focusing on making the fixer. You see, we are just focusing on making the fixer. We just need to call the function and provide the argument that we want. So it's as simple as ABC. So you can replace your code into directories. You can place your code into directories instead of just putting your file just like this, Sarara Haka. You can just put it in a folder in this. Maybe you are creating a module for solving different mathematical problems or chemistry problems. So maybe for logarithm, you can create logarithm here. So for geometry, you can put this. You can create a folder called geometry. For mensuration, you can put mensuration. For bearing, you can create a folder for bearing. So if you create a folder or directory, you create a file in it. For example, here we create this picture inside this folder called or directory called module. So in this module, you can give it any name you like. Remember the naming convention of a variable. Don't put space or whatever. So if you are putting your code inside, if you are creating a module. So what you just need to do, you need to provide the folder name. Then you put .pixar. Remember here we just write import. You see, import pixar. But if the file, the module is in another folder or directory, so you have to use dot operator. So you say import module.pixar. So this is the file, and this is the directory where this file resides. So here we have three different, we have two different dots. We say module.pixar, .make pixar. So this is very lengthy. Later we will learn how to use alias. So in summary, this is what we do. We call the module name, then dot function. This is what we do. When we import the module, then each function in the module is available through the following syntax. So if you have many functions, then you import this module name, just like Pixar, then you put dot operator to access that function. So if the function accepts parameters, you provide the parameters here. If it doesn't, you just leave it as it is. So let's move to the next, importing specific functions. We have to finish. Let's finish this. Importing specific function. So instead of importing the whole module, you can just import just specific function you want to use. So this will make your code run faster, because instead of importing what you don't need, why can't I import what I need? I need just this. So let me just use it. Just like your smartphone. You can't just keep going to Play Store and keep downloading apps that you don't use. Why? I need this app, let me just download it. If I don't need it, why should I import it into my phone? Why should I install it? So just like that, you can just import specific package to your program. How do you do that? So instead of starting with import, then the module name, what you just need to use is to use from. From module name, import the package, the functionality you need, the function you need. You are just saying, hey, Python, from so module, please, I want to use this function. Just take this function for me. I want to use it. So for example, here we say from Pixar. So the Pixar is our module. Then we say import this function. So here we are importing. Imagine there are hundreds of functions there. We are just interested on this function, make Pixar. So when you try to make use of any other function in Pixar, it will not work. So if you need another function, you can put comma and put it here. Maybe you want to import like 2, 3. So you can put all the 3 here, separate them by comma. Then here you can call the function. So let's run this. So when we run it, it works as expected, just like this one. Like this one, like the rest. So you can use as, this as is a keyword to give a function an alias. So you can give a function another name, just like nickname. This alias means nickname. You can just nickname your function for easier for readability, maybe, so that you can remember the name of the function. Look at how we just make use of this make pixel, but look at this lengthy code. So if we like, we can write as just pz. So instead of using this line, you can just say pz here. You can write pz here and it will work. So look at the output here. So when we run it, we get the same output. So when importing function, you can give it a name alias. So sometimes you may want to give a function a different name that is easier to remember. That's the rationale behind using alias. So you can use as keyword to create an alias for a function. So when you want to give a nickname to a function, just use as after the import statement, then you just put as, then you give the name you want. So for example, instead of calling make pixar here, you can call it MP. So here you see import from pixar, import make pixar as MP. So here we are renaming this one. We are just calling it, we are not actually renaming, but we are giving it another name called MP. So instead of writing make pixar, when calling the function, we can call it with this name. Just like how we call our parents. We say dad, mom, but they have their own name. So this is something. So here we say MP instead of writing make pixar. So we say MP, so we are calling this function, but with another name. We are just give it another name so that we can, maybe we want to type faster, then we can use this shortcut. So this is it. So when we run this code, we get the same output as before, you see. So using as to give a module an alias again. So you can give your module, as we did before, an alias as well. Import fixer. So fixer is the name of our module. Here is the alias we have given our module here. So here we can say v dot the function in the module, then these are the parameters we are going to provide. So when we do this, we get the same output as well. So if you like, sometimes because the module you are importing contains many functionalities that you are going to use. So instead of importing one by one, you can import all the module, because you know that you are going to use majority of the functionalities stored in the module. So to do that, what you just need to do, even if you don't know the functionalities, you can just use from this import all the functions here. So this star means all. So you just need to, you just shortcut up that represents all the functions in the module here. So because there is only one, we can just use only one. If we have many, then we can use many. So when we do this, we get the same output. So you see we have so many options when importing modules. So key points to remember when using module. So using from module import this. So the asterisk that I have already explained, import statement copies every function from the module into the current program. So it will take every function you have in the program to just place it in the RAM of your computer so that you can use it. Then this allows calling function directly by name without using dot notation. So you can just call the function without the use of dot notation because you call the function. Yeah. And what's the drawback of this? What the disadvantage of this? It is unsuitable for large modules. You didn't write as function or variableness conflicts may arise. So if the module you are going to import is very, very large, it has so many functions, it can interfere with the function that you wrote. Maybe they have the same function names or variable names or some parameters. So you may have some conflicts. So Python might override functions, or you already define functions. So Python, when you import, so Python may override the functions that you've already written, or you can override the function in that modules you imported. So you can get unexpected result because of this. So that's why it is advisable to import the function that you just need. So the best practice is to import only specific function that you need. So if you just need this, just import the ones you need and leave the rest. So alternatively, import the entire module and use the dot notation to maintain clarity. So you can, instead of using from module name import star, you can just import the entire module. So in doing so, you can use the dot operator to access the function instead of just using the function without use dot operator. So again, recognizing from module name import this in other code is important. So you need to recognize it in other code, but avoid using it in your own project. So it is better to know it, but you make sure you don't use it if you don't need it. So only use it when you are certain about what you are doing. The next is function styling guidelines, which we have already discussed about this. So descriptive name, whenever you are creating a function, whenever you are defining a function, so use descriptive name. Use lowercase when possible. When we go to OOP, we'll understand that whenever you want to create a method or function, we use lowercase and underscore. That's why you see I usually use underscore when creating, like first name, I use first, then I use underscore, then I use name. Last name I use last, then underscore, then name. So make sure you use that. You use lowercase and underscores for function and modules names. Then choose names that clearly indicates the purpose of the function. So if the function is to calculate area of cycle, then you can call it calculate area of a cycle, for example, or calculate area, for example, because the function is going to calculate areas. Compute derivative, for example. So you call it compute derivatives, or maybe differentiate. Then documentation. So each function should have a concise comment. So we use docstring format, not using hash. So that's why I say that you find this kind of comment in functions. So use docstring when documenting your function. So you define the function, then immediately after definition, you can put docstring format to write about that function, what the function does. So you do it directly after the definition. So docstring should describe the function's purpose, required argument, and return values. So this is what we are going to put. What's the purpose of the function? What's the argument that are expected from the user? Then what will be the return type of the function? So these three things are very important when defining your own function. Then provide default parameter values sometimes. So avoid spacing. So avoid spaces around the equal sign when specifying default values. So like this, we have the default value. So instead of putting space between this variable name and this value, you should avoid the space. You don't need space here. That's a good style. Although your code will work, but it is advisable to neglect the space, to avoid using space. Then use the same convention for keyword argument in function code. So use the same convention as you use. This. So line length. So we also discussed about this when discussing about PEF 8 guidelines. So each limits each line to 79 characters or less. So you make sure that each line does not exceed these characters. It will work, but you are advised to use 79 or less characters. Fine. Then when handling long function definition, if parameters exceed this 79 characters, break the line after the opening parenthesis. So like this one. Because if you put this one, maybe it will be lengthy, then you can break the line. Just press enter and just continue from where you stop. So you keep here, you put the code for the body of the function. So you just indent subsequent lines of arguments. You just indent them just like this one. You indent, you keep footing. If there are many, keep footing. So editor support.
Yes.
Yes, I think that's all. I'm sorry, I was muted. I didn't even notice that I was muted. Is there any question? If there is no question, then we can call it a day.
So call it a day.
Yes, sir.
Okay.
Hello, sir.
Yes.
Yes, sir. About the remaining chapters in our notebook, we haven't seen them. It's like you didn't push the remaining chapters.
No, I push it today, like 30 minutes to the hour.
Okay. Let me,
Yes.
thank you.